Practice 4-2. We are using only SSS and SAS to decide if these triangles are congruent. So I can look at this number 1 and say that AB matches up with CB because of the little hatch marks that they showed me. Okay, so that's one side. I got a side. Now I need, here's another side. DB is actually congruent to itself. That's the reflexive property. So I have another side, and look at that. They marked a little arc mark in here and another one over here. So for this triangle on the left, ABD, that's the angle that's included between the two sides that are congruent. And over here, CBD, I've got the angle included with the two sides that are congruent. So that's actually SAS. And of course, let's practice the congruence statement for this one. And it'll look like this. Triangle ABD is congruent to triangle CBD. Number 2, I have a side matched up with a side. I have another side matched up with a second side. And there are no more marks. So I don't know anything else about these two triangles except side, side. That is not a postulate, so we don't know about the congruence here. Number 3, we have a side. We have a second side matched up with two sides over here, and then an angle. Could this be side, angle, side? Well, if it were side, angle, side, I would be talking about the angle that is included between the two sides. So if I'm using these two sides that are congruent, for SAS, I must use the angle that is included between the two sides. Is that what's happening here? No, it is not. This is the thing that doesn't exist. Side, side, angle. So if you wonder if you have side angle side or side side angle, trace what you've got and say the names. I have a side, I have a side, I have an angle. It doesn't exist. Let me go over here and trace this. Well, I'm going to start with an angle, a side, and a side. That doesn't exist. We talked about this, that there is no profanity in the triangle congruence theorems for geometry. So, number 4. First, we know that number 3 might not be congruent. Number 4, we have one side matched up to one side. We have another side goes with another side, and third side matched up with a third side. Yeah, that was pretty obvious. SSS. Now, what is a good name for this? Let's go with STU, triangle. STU is congruent to, where do I begin? Well, the S side here, let me clear this up for a second. The S side was between the side that had 2 hatch marks and 3 hatch marks, which means that I must be talking about V as the other vertex. Okay, I can handle that. And then I went from S to T. Well, T is the side between the 2 hatch mark side and the 1 hatch mark side. So that must mean I went from V to X, leaving W as my last vertex. So there's your triangle congruence statement. Number 5. If this is a right angle, then so is this one, because we can always assume that a straight line truly is a straight line. So if I know that there's 90 degrees here, then this is also going to be 90. So now I have this side would be congruent to itself, and I have an angle here. I need another side or an angle somewhere. So this is not enough information to say that these are congruent. Number 6. We have a side matched up with a side. Then the very next thing I'm going to trace is the angle. Oh, goody. And then a third side. Hey, side, angle, side, you bet. Now for the triangle congruence statement. Let me do CDE congruent to has to be F, G, H. Number 7. I got a side matched up to another side. Then I'm going to trace an angle. Goody. Then I go to this one right in here. That's another side that's congruent to itself, the reflexive property. So here I actually do have SAS, and it's because of side, angle, side. So the congruent statement would be triangle JKM congruent to triangle LMK. Ask me if that doesn't make sense. Number 8. We see that PN would match up with PQ and that NR matches up with QR, but is there another side that's congruent? Why, yes, there is. PR is congruent to itself. So that means we have just shown that there are 3 sides congruent. My triangle congruence statement can therefore be PNR. Let me clear these out so you can see them better. PNR congruent to PQR. Number 9. Let's see here. I've got an angle. I'm sorry. I've got a side congruent to another side. That's good. Ooh, and I got a second side congruent to a second side. That's a step. Now, if I just did side, side, the only other thing that can go here is a third side. Do I have a third side congruent? No, you can't be sure of that. So I don't have SSS. But wait a minute. What about those vertical angles in there? What vertical angles, you say? The vertical angles that are congruent, because that's the definition of vertical, when I trace those 2 lines. Oh, so let's see. If those are vertical angles, and you can assume that vertical angles really are congruent, even though the diagram didn't mark them, you can assume that the angle in here would be congruent to the other angle. Hey, does that help us? Well, that would be an angle, then a side, then a side. Yeah, that's the theorem that doesn't exist. Angle, side, side. So this one, you cannot be sure that these are congruent. Now then, draw a triangle. Pretty open-ended. All right, let me go. Triangle. What is, label the vertices A, B, and C? What angle is between BC and AC? Well, that would be this angle right here. So I will name that angle ACB, because C is the vertex of the angle between these 2 sides. What sides include angle B? Well, let's go with, see if oh no, I erased the whole thing. We're talking about angle B. Well, that will be made up of segment BA and segment BC. So this was 10, this is 11. Number 12, what angles include this segment, AB? Well, that means that there's an angle over here and an angle over here that are on either side of this segment. So that would be angle CAB and angle CBA. What side is included between angle A and angle C? Well, between angle A and angle C, I've got segment AC. Now we get to fill in some of the reasons. So anytime they're looking for reasons, these are things that should be written on your note cards. So now, why can we say that AB is congruent to DC? AB congruent to DC. actually gave that to us because the diagram shows it. One hatch mark matches up with the other hatch mark, so those are givens. Also, angle BAC is congruent to angle DCA, so these angles are congruent. Again, it's given because the diagram shows that. Now, how about this? AC is congruent to CA. That sounds an awful lot like something is congruent to itself. And what do we call that property? Reflexive. So now we have just established that for the bottom triangle, a side, an angle, and a side match up to and are congruent to another triangle's side, angle, and side. So your reason for saying this entire triangle is congruent to this entire triangle is simply SAS. And it's not just your grandparents' shoe brand. So, number 15, write a proof. Write a proof. We have a diagram that shows EF is congruent to FG. We also see from the diagram, the givens, that DF is congruent to FH. So, let me make one statement here, and I'm going to copy all this stuff. Congruent. I've copied all this, and the reason for saying this is because it's given. The diagram shows it. Next, I need to say something in here, and finally I need to prove that this triangle, DFE, is congruent to the other triangle, HFG. Well, if I have these two sides congruent to these two sides, at this point I either have to prove that this side is congruent to this side, or I could say something about this angle congruent to this angle. Does that look familiar? Yeah, it should. So now I'm going to say that angle EFD has to be congruent to angle GFH. Because why? Because vertical angles are congruent. And all you have to write is vertical angles there. So now I've just proved that this side, this angle, and the next side match up with this side, an angle, and the next side. So that means that this triangle is congruent to this triangle by SAS.